Hi, everybody. We're back, and we're looking now at example 3 in our introduction to chapter 3, combinatorics. And this one reads as follows. Standard license plates in New York consist of 3 letters followed by 4 numbers. So, for example, JRB 4412 and MMX 8901. And the question is, if that's the case, then how many license plates can we make before we run out? So how many different license plates are there? And here's how we're going to solve it. We're going to think of a license plate as being like a list. It's a list of letters and numbers. Yeah? In this case, what is the length of a list? It's a list. The length of a list that represents a license plate is 7. So this is a list of length 7. If you wanted to really write it as a list, you would write something like J, comma, R, comma, B, comma, 4, comma, 4, comma, 1, comma, 2. But we're just going to take that to mean JRB 4, 4, 1, 2. We're going to write it without the commas and parentheses. Okay, so this is just a way of thinking of a license plate as a list. Okay. And what we want to do is count the number of possible different license plates. And so we're going to count the number of lists. We want lists of length 7, and we want those lists of length 7 to satisfy the following thing. If we have a license plate that consists of 7 digits or 7 characters, then the question that we're asking is how many options in each position. Now, in the first position, this is a letter, and there are 26 letters in the alphabet. So there's 26 different options that could go in there. That could be an A, or a B, or a C, or a D, or an E, or an F, etc. In the second position, well, we're putting another letter, and there are 26 letters in there. Is there any rule about license plates cannot repeat letters? No, there's not. It's fine to repeat the same letter. So just because we have a letter here doesn't mean we can't use it here, and that means it's still 26 letters that we have to choose from. And in the third space, it's going to be 26 letters to choose from there as well. So this one is also 26. After that, we come to numbers, and numbers are a choice not out of 26 things, but out of 10 things. The numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0, and now together that makes 10. So there are 10 options there, 10 options there, 10 options there, and 10 options there. And what is the total number? The total number is, well, it's 26 times 26 times 26 times 10 times 10 times 10 times 10. We could shorten that by writing it as it's 26 cubed times 10 to the 4th power. And then to get the answer to that, we put it into a calculator. I'll do that really quick. 26 to the 3rd power times 10 to the 4th power. And the number I get is 1757 6 0 0 0 0. And if you think about where the commas go, there, they'll go there. So this looks like 175,760,000 license plates. That's the number of license plates that we could get in New York State, for example, before we ran out of different plate numbers. There are still under 10 million people in New York City, and not all of them have cars. And so if we sort of extrapolate out to across the rest of the state, there's fewer people, but more of them drive cars and so on. We're still nowhere near 175 million license plates. So I think that we're fine. We have a lot of room in the license plates, in the world of license plates. We're going to be able to keep going for some time. Okay. That's it for problem 3. Now let's take a look at example 4. In example, so we also have example 5 listed here. Just ignore that for now and focus on example 4 here. We're going to consider making lists from this set, A, B, C, D, E, F, G. Now look, in some cases, like in license plates, we don't care if things repeat. It's okay. You know? In other cases, we are going to care whether things repeat. We're going to say no repetition is allowed. And it depends on the kind of thing that we're counting. And so, because of that, we sort of have these two phrases. If we allow repetition, like in the case of license plates, we call those repetitive lists. This is also like building a list with replacement. If you've heard that term with replacement, some probability and statistics courses teach some combinatorics, and they use that phrase. And then if repetition is not allowed, if you're only allowed to use each item, each letter, or each number once, then we call that a non-repetitive list. And that is also referred to as a list without replacement. Okay. So that's just a little bit of terminology. So let's see how many length 4 lists are possible. So we're building lists of length 4, and we're building them by taking the entries from this set A, B, C, D, E, F, G. And let's just, as a reality check, what is the cardinality of this set? Well, it has 1, 2, 3, 4, 5, 6, 7 items in that set. 7 members. Cardinality 7. That's going to be important when we start calculating when we're building our lists. So let's see. A. These are lists of length 4. 1, 2, 3, 4. An example of a length 4 list would be B, C, D, C. Repetition is allowed, so it doesn't matter that I have a C in there in the second position and in the fourth position. And all of those entries in my list come from our set that we're given here. And if you think about building a list by filling in boxes, the first box, it has to be a letter, and it has to be one of those letters, so there's 7 options here. The second box, well, it can be any letter, and it's okay if it repeats. So there's still, you can choose any one of those 7 letters here. You can choose any one of those 7 letters here, and you can choose any one of the 7 letters here. Altogether, that is 7 times 7 times 7 times 7. That's 7 to the 4th many lists altogether. And let me see, this is 7 to the 4th is 2,401. That's how many that's how many repetitive lists there are with entries taken from this set. Okay. Let's take a look at B. What if repetition is not allowed? So in this case, we're still building a list of length 4, but the example that we had here no longer counts because we're not allowed to repeat a letter anywhere in the list. So an example of something that would work would be if we made it B, C, D, A. That's fine. And any combination of the letters as long as we don't repeat one. Okay. So let's think about building a list like this. The first spot here, when we set out to make a new list, we can use any one of the letters in the first spot. So any out of 7, which means that there are 7 options here. Okay, I'm going to go ahead and build an example as we go. So let's suppose that I put in E as the first letter. Okay. Now, when we go to the second letter, I can choose any one of those letters, but I can't choose E, which means that I no longer have 7 options to choose from. I only have 6 options left. There's only 6 letters left. So when we come to this second one, there's only 6. I'm going to choose D. Now, I can't use E and I can't use D because we can't repeat any letters, which means that in the third place, there's only 5 options. And let me see, I'm going to choose A here. And then for the fourth place, I'm not allowed to use E or D or A, but I can choose any of the other ones. And there are 4 other options that I can choose from. Oops, here we go. So 4 options, and I'm going to choose B. Okay. In this one, since repetition is not allowed, the number of options goes down each time because you've already used up some of the options. So the total number in this case is 7 times 6 times 5 times 4. And that is 840. There's a lot less of those. So if we allow repetition, it's more than 2,000. If we don't allow repetition, we get shrunk down to only 840. That's part B. Let's take a look at C. Repetition is not allowed, and the list must contain the letter E. Okay. So, tricky. The problem is that we have a lot of freedom if we build one of these guys. We have a lot of freedom about what letters to put where. It's just that in the end, we have to make sure that we've used E. So this is a little bit harder to think out. Instead of listing all of the possible lists like this, I'm going to do this in the following way. We know that there is an E in here somewhere. Yeah, an example of one of these would be EDCA. Another example would be BAEC. And of course, there are many more. What you'll notice that these have in common is they all have an E in them. And so, of course, there's a lot more of these, but all of them are going to have an E in them somewhere. So let us do the following thing. We know there's going to be an E in there, all right? And there's only going to be one E in there. So let's first say, where is the E? And, of course, you have four different options of where the E goes. It could either go first and then have three letters that come out of it. Or it could go second, and then you have the other three letters. Or it could go third, so we have a letter, and then an E, and then a letter. Or it could go fourth, so a letter, and then an E. And what I'm going to do is I'm going to count how many of them there are where the E is in the first position, how many there are where the E is in the second, how many in the third, and how many with E in the fourth, and then I'll add those totals up to get the total number of different lists that have no repetition and also have an E in them somewhere. Okay, so let's do it. Here, I'm going to zoom in a bit. I'll change my color to green and make my pen a little bit smaller so I can write legibly. And right now I'm just going to look at this first one. Let's imagine that we're building a list. Remember, looking back at the instructions, this is C. Repetition is not allowed, and the list must contain an E. And we're taking it out of this A, B, C, D, E, F, G. Okay. So in the first example here, I'll just... in the first types, there's basically 1, 2, 3, 4 different options that we have to consider. Okay. In the first option, E is in the first place, and then if we're building the rest of this list, this box has how many different options for the letter we choose here? Well, we're not allowed to choose E, but other than that, we're wide open. So there were 6 letters altogether. If we take out the, there were 7 letters altogether. If we take out the E, there's only 6. In the next box, we've already used E, and we've used one other letter in the second box. So in the next box, there's 5. And then in the last box, there will be 4, since we've used up 2 letters along with that E, so that's 3 letters altogether that we've used. Okay, so in terms of how many lists there are that have an E in the first position, there are 6 times 5 times 4, many. If we know the E is in the first position, we don't have any freedom to choose anything there. E is in the first position, so we just count the options that we have in the other positions. 6 times 5 times 4 is, let me see, 5 times 6 is 30, and 30 times 4 is 120. So there's 120 different lists that have that E in the starting place. What about in this one if we put the E in the second spot? So we've already decided the E will go here, and now we need to fill in the other 3. So when we go to fill in the first one, we can use any letter we want except E. We already put the E in over here, so we can only choose out of the other letters, and there are 6 of them. So there's 6 here. When we choose the third entry in our list, there are going to be 5 options, and because we've used E and we've used one other letter. And then for the fourth entry in our list, there's going to be 4 options. So you'll notice that this also turns into 6 times 5 times 4, which is 120 different options that have E in the second spot. Thirdly, if we choose E in the third spot, we're going to have 6 options and 5 options and 4 options in the same way, and this is going to come out to 120 options there. And this is going to be exactly the same, 6 and 5 and 4. 6 times 5 times 4 is 120. Now, if the E is here, we get 120 different lists. If the E is in the second spot, we get 120 different lists. If the E is in the third spot, we get 120 lists. And if the E is in the fourth spot, it's 120 lists. If we combine all of these together, then we get a total of 480 lists altogether. So this is our solution for part E. I'm sorry, for part C, which is repetition is not allowed, and the list must contain an E. Now, the last one. Repetition is allowed, and the list must contain an E. So, this one basically is crying out to be done wrong. There's an easy mistake to make. The easy mistake to make is to approach it like we did the first one. I'm sorry, the one just before this. If you look back and you gave examples on each type, where the E came first, you would have an example like this, E, A, B, D, and then you would have an example like A, E, D, C, and then you would have an example like D, F, E, G, and then an example like C, D, A, E. Okay. And if you gave me any one of the lists that had no repetition and had an E in it, it would fall into one of these categories. Yeah. These are examples of each of the categories. Okay. If we try to do a similar thing here, if we try to say, because here repetition is allowed, but it has to have at least one E in it. So this is what our problem says. Repetition is allowed and must contain an E, that is, must contain at least one E. So if we try to do this the same way, here's the trouble. We could think about all the lists that start with E and then have 3 other things. And we could think about all the lists that have E in the second place. And we could think about all the lists that have E in the third place. And all the lists that have E in the fourth place. So this seems like it would be the same. This is a tempting way to do it. Since repetition is allowed, the calculation that we would do would be something like, we've chosen E in the first spot, but here we can choose anything out of all 7 letters. And so here the number is 7, and 7, and 7. And that makes you think, because you can choose any letter that you want for each of those other 3. So that makes you think this is just 7 cubed. And it makes you think that all of these are going to be equal to 7 cubed. And the question is, why can't we just add these up, the 7 cubed plus 7 cubed plus 7 cubed, 4 times, and get the solution? So first of all, 7 cubed is equal to 343. All of these are 343. And if we take that and add the 4 of those up, we get 1,372. Okay, so this seems like a pretty good candidate for an answer, but unfortunately, this is wrong. And here's the reason why. If we think about what we're counting here, the first category, it's trying to count up all of the different lists that have an E in the first spot. Yeah. And so if we list some of those, some examples would be something like, E, D, C, D, because we can have repetition, it's okay. E, D, A, F, and so on, etc. Okay. In the second one, we would get things like A, E, C, B, or A, E, A, A. In the third one, we would get things like D, B, E, B. And in the fourth one, we would get things with the E at the end, B, 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 E, for example. Now, question, if I give you an example, here's an example, you tell me which category it goes into, 1, 2, 3, or 4. It's like we're collecting all of these different lists into these 4 different buckets, and we want to make sure that we've got all of them accounted for. So, for example, if I give you this list, EDAC, we know that this goes into bucket 1, right? It has an E in the first spot. If I give you DDEA, this goes into bucket 3. It's one of the ones that we counted here. And if I give you, whoops, EDAE, this one is a little bit of a puzzle. This one, it appeared in the first bucket. It was one of the ones we counted, because it has an E in the first spot. But it also appears in the last one because it has an E in the last spot. So it was one of the combinations we found here. Because remember, when we found these combinations, we could choose anything we wanted for any of these 3. And we could certainly choose an E, and then a D, and then an A, and then have that E still at the end. So this was also in bucket 4. And here's the problem. The fact that this list showed up in 2 different buckets, in bucket 1 and in bucket 4, it means that this particular list, it's one of the 343 that we put in here, but it's also one of the 343 that we put in here. And that means when we add these up, we are counting this list twice. We're counting it once in the first collection and once in the last collection. And because we're counting this twice, this total number is not the total number of different lists. Some of the lists in this bucket are the same as lists in this bucket. And in fact, there's overlaps between any of the 2 buckets. If you choose 2 buckets, we can find a list that belongs in both of them. So the problem is we are double counting this. We are counting this twice. And so, because we're counting that list twice, the answer that we got, 1,372, that number's too big. We've counted some lists more than once in there. And that's not right. We want to count each of these lists just once and then figure out the total. Okay. So, basically, we are stuck at this point. We need a new idea. Okay. So here's the way that the new idea is going to work for D. D is repetition is okay, and then must have an E. Okay. So here's what I'm going to do first. I'm going to look at all of the lists that have repetition. So this is all lists with repetition allowed. With repetition. With repetition doesn't mean there has to be repetition, it just means that it's allowed. So let's think of that as the size of this circle. These are all of the lists that can have repetition or not. Repetition is allowed. And we can divide this up. I don't know if it's a half, so I'll just cut it over here. We can divide this up into those with an E and those with no E. And what we want is to know how many of these there are. Okay, but we can't find an easy formula for this. Here's what we're going to do instead. To find this thing, we're going to look at this slightly differently. We're going to see if we can find how many there are in this entire universe of all lists with repetition. And then we're going to see if we can subtract off how many of those that have no E in them. So let's just figure this out. All lists with repetition. These are lists of length 4 taken from the set A, B, C, D, E, F, G. And with repetition allowed, the number of lists of length 4 with repetition allowed, we figured that out in part A. It was exactly 7 to the power 4, which is 2,401. 7 to the 4, 2,401. Okay. Now, that tells us the size of the entire thing. And of course, this is not the answer that we're looking for, because this counts all of the lists, whether they have an E in them or not. And we only want the ones that have an E. So let's go ahead and figure out how many of those we counted that have no E in them. So this is sort of coming from this side right here, lists with no E. So these are lists of length 4. Repetition is allowed, but they cannot have the letter, I'm sorry. Repetition is allowed, but they cannot have the letter E in them. So those with no E. So the question is, how many lists of length 4 from our set with no E? And to figure this one out, we can do the calculation. It's like this. These are lists of length 4. Repetition is okay, but we're not allowed to choose an E, which means that if you think about building such a list, in the first slot, you can have a total of 6 different options there, because you can choose A, B, C, D, F, or G. So there's 6 different options here. Similarly, in the second spot, you're allowed to repeat, you're just not allowed to use an E. So there's 6 of these. There's 6 possibilities in the third spot, and there's 6 possibilities in the fourth spot. And so altogether, this is 6 to the power 4. And that is 1,296. Okay. What's the 1,296? It's the number of lists of length 4 with repetition allowed that have no E in them. Now, we want to know this one's those with an E in them. Well, look, either they have no E in them or they have an E in them. So these are like all the ones that are left. So what are we going to do? We're going to take all the lists, that's 2401, and we're going to subtract off the ones that have no E in them. That's 1,296. And what we'll be left with is the list that do have an E in them. So 2401 minus 1296. And that's 1,105. This is the correct number of repetitive lists with repetition allowed that contain an E. So this is our answer to part D. If you compare it with the bad answer, the wrong answer that we got here, 1,372, our original wrong answer was off by a couple of hundred, and that is accounted for by the overlap between these different categories that we said up here. All right, that's it for example 4. For example 5, I'm going to let you guys work through this. This has to do with the notion of factorial, and I encourage you to read a bit about that in the lesson. That's all for now.